Number 47. Write the balanced nuclear equation for the production of the following transuranium elements. And then we have lawrencium, which is 257, made by the reaction of CF250 and B11. Okay, so it seems like we just have to come up with some type of balanced nuclear equation for what's going on here. Now, when we're dealing with nuclear equations, we have to write them in nuclide notation, which means that we need to know 3 things per every particle or element. The element symbol, the mass number, and the atomic number. I like to write them in these little cute little boxes like this, right? So, according to the wording of what's going on here, lawrencium, that's a cute little name, lawrencium, right, is made by this reaction. So these two guys reacted with each other, and they made lawrencium, right? So this lawrencium has to be the product. And it's the product of these two coming together. These are my 2 reactants. So I do have some type of outline here, a blueprint, right? We got CF 250 plus the boron, boron B11, and this will turn into lawrencium-257, so I'll give one more of this, and then we will see if we are balanced. If not, we'll just have to add some more subatomic particles, but we will see. Okay. So, CF250, right? CF, that's not curium. CF is Californium. The Californians. Yes, Californium, I think, right? Californium. Yes. There's so many different songs with California in it. Like, so many of them are going in my mind at one time. You have, what was that? Tupac? California. And then you have, Dream of California. And then you have Hotel California. And my brain is just gonna, rupture with, now the SNL, the Californians. Let's get back to chemistry, shall we? Just a little insight of what's really going on in my brain at all times. All times, there is always a song playing in my head. But I digress. Let's get back, shall we? So, Californium-250, they tell us the element already, right, which is CF. So I got CF going on here. The 250 is the mass number. Now, they have to tell us that because the mass numbers can change from one element to another isotope of that element, right? Because your number of neutrons can change. So the mass number can change as well. Now, in this case, they told us that, we have 250 as the mass number. Mass numbers always goes on the top. But now, what is going to go here, right? This is the atomic number. And atomic numbers never change for that specific element. So they didn't tell us because they assume that you have the periodic table out in front of you and you're going to look at californium on the periodic table. The atomic numbers are always the beautiful whole numbers, right? They're not the decimals because that's the average mass. But for californium, it is number 98. And I'm just going to triple check. Yep, 98. And this guy's done. Now let's do the same type of rationale for boron. So capital B. They told us that we had boron 11, so I have to use that number as my mass number. And then I'm going to look on the periodic table to find out what that atomic number is. Boron is lucky number 5, my lucky number. Now, we got one more to go. Lawrencium, right? Lawrencium is all the way at the tail right end. Lawrencium is LR. So we'll say that, LR. I don't like how these are coming out. Please don't let me get stuck in a loop here. Okay, Christina, just accept that it's not perfect. Okay, cool. They told us that it was 257, So I'm going to put it up at the top, 257. And now let's just get that atomic number. Lawrencium is 103. So let's see if we are balanced, shall we? 250 plus 11. 250 plus 11 is what? 261? Yes. That does not equal 257. So that's not good. We're going to have to change that. And for the bottom, 98 plus 5, what is that? 103, right? 98 plus 5, you gave it 2, you got a 3. That looks good. So the bottoms are good, but the tops aren't. But since this is the reactants that are happening, I can't really add anything to the left side. But that means that I could pick up the slack and add something else on my product side. Now let's see. We already discussed that 98 plus 5 is 103 already. So I don't need to add anything in the numerator. So I'm going to put a 0 here. But now 250 plus 11 is 261. This obviously does not equal to 257. So 257 plus what number will get me to 261? If we just subtract 257 from 261, what do we get? We get 4. Right? So 57 will get me to 60, and then 1 extra will get me to 61. So I know overall I want to add a 4 here. But then I have to say to myself, what atom or what subatomic particle has a 4 on the top and a 0 on the bottom? I don't know any, right? So I have to kind of rearrange this to fit a subatomic particle that can maybe get me here. Now the 0 on the bottom is going to give me the answer because there's only one subatomic particle with a 0 on the bottom. Do you know what it is? It's a neutron. A neutron is not a proton, so it has no atomic number, right? So 0. But a neutron has a 1 on the top because it's only got one neutron, and that's the mass number, right? Mass is protons plus neutron. You got one neutron, so just a 1 up there. And this is lowercase n. Oh boy. That's fine. That's not fine. That's not fine. Okay. But now, remember, we said that we needed lucky number 4 here. But when you are going to add multiple subatomic particles, you can't just go in and say, okay, I'm going to change that, because that's not a neutron anymore. We want to say that we have 4 neutrons. And now we treat that number as a big number in the front. How many neutrons do we need? We need 4 of them. Because 4 times 1 is 4. And then 4 plus the 257 gets me the 261. And this now is all balanced. And we are done. That's the end. What'd you think? I hope this helped. Thank you so much for coming here and viewing, the videos to help you guys in your chem class. We have physics videos on the channel. We got math videos on the channel. If you guys ever needed help with that as well, tell your friends, tell your classmates about this cool channel. I think it's pretty cool. Love helping you guys out, and I hope you have a great day. There's memberships on the channel for anybody who wants to help the channel out a little bit more, get more videos pumped out. But yeah, thank you so much for the support thus far on this journey. And it's all because of you guys. So thank you so much. I'll talk to you soon, okay? Have a great day. Bye-bye.